Hey everybody, this is Larry. This is, I think, day 17 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So I have two things I want to go over before going for the problem. I'll click on it anyway. One is that, one thing that I like to do in my Discord and servers and just life in general is to celebrate victories here and there, big and small. And today, or for me, it's earlier today. For some of you, maybe yesterday. I did the bi-weekly contest and I finished 13th in the US and like 21st. So yay! It's been a while, I feel like. So always nice to celebrate that a little bit, even if hopefully we'll get to a point where it's so boring that it's like, why is Larry celebrating? He does it every week. But not there yet, or at least not recently. And then the other thing that I wanted to say is that, this is just a problem. One of the other things that I want to say is, there's this quote that I've been on my mind. I've been kind of trying to figure out how to tie it together, but really it is something that one thing that I've been focused on the last couple of months. If you've been watching my Leetcode every day, hopefully, or at least like frequently enough, is that I've been working out a lot. I've been kind of focusing on my health. I had at a certain point high blood sugar. I have to double check that again. Hopefully it is improved, but not everything happens in a day, right? Or even a week, or even a month. So there's this quote that kind of I think about a lot when it comes to workout and health and stuff like this in general, is that people tend to, because the quote is people overestimate what they can do in a day and underestimate what they can do in a year. And I think Leetcode is a grind, everyone, talks about it as a grind, and it is, but that means setting proper expectations. And it means that, doing things in a way that is sustainable. I talk about the handstand thing a couple of times here, right? The perfect handstand. I'm not going to go over that again, but the same idea is still the same, right? If you feel like you're like, oh, I have this random goal, and every goal is relatively arbitrary. All you can do is just try to be a little bit better than you were yesterday, and there are many ways to do that. And and even that is not like always true, right? These graphs are kind of, because basically, if you're able to take 2 steps forwards and only 1 step back, it doesn't matter how, given enough time, you'll be way far ahead, right? And this comes up actually in muscle building as well. Hopefully, not quite yet, but I'll do a before and after thing at some point in the future, maybe. If it inspires you, let me know in the comments if it inspires you. But even in like muscle building and fitness, is that talking about muscle building, a lot of people try to do this thing where they like grow very slowly, but the best way to grow muscle is actually just to grow at a pace that is fast enough to get the muscle. You'll gain a little fat, but then you'll just spend some time to lose that fat instead. So then your muscle mass will go down a little bit, or your muscle mass will stay up, but your weight, you'll spend some time like losing that fat and then go up again. So not everything is a linear line, not everything is a straight line, not everything is a line, maybe, but I think if you set realistic goals, if you kind of think about who you want to be, not just tomorrow, but in a year, or maybe even longer, and then you could work toward it. I think there is also another point to be made about arbitrary goals. I think rating is kind of a proxy, but it's a measure for progress. But as a goal, I don't think I agree with too much. It's everything arbitrary, and if you make goals that are just like at a certain point, it's very demoralizing if you don't set realistic goals. Anyway, and I wanted to bring up use this opportunity to kind of just to in my Discord channel, I definitely have like a victories channel, as we talked about, so people can celebrate the victory. And this is just Gia's graph, and you can see it takes a while. I wish there was like a time thing, but it takes a while to get up there. But he's been working hard, and definitely a lot of props to that. and he's been making, you know, a very steady goals. Some of that I don't necessarily agree with, just because at a certain point, like, you know, like it's like me saying my goal is to be the best in the world in the next year. It's like, that's, you know, that may not be, at a certain point it may not be up to just me working hard, you know, to be frank. But I can be better than I am now if I work hard, right? So yeah. So just a quick shout to Just Cheer, and there are a lot of people on my Discord server that supports each other and you know, push each other to be good. So I'm kind of happy to see that, and yeah, and definitely, you know, maybe, I don't know. I did not intend this to be an ad for the Discord, but definitely if you could swing by, that, you know, that would be kind of cool. And I think some of it is if you're able to find a buddy there and find proper accountability, to keep yourself honest and keep yourself humble and keep growing, then, you know, it's a good place. If you, I don't know, this is a little bit of a side rant, sorry. I just feel like the last couple of days, there were a couple of trolls in the coming in the server where they're like, you know, where the point is like, I'm like, why are you here if you're not here to learn? Like, I'm here to teach if you're willing to, but if you're not gonna, like, if you're trying to teach me stuff, then I'm like, I don't know. Maybe I'm not willing to learn. Maybe that's my fault. At least not on stuff that I already pretty confident about. I think one thing that people make a mistake on, and this will be my last chunk before I solve this problem. One thing that I think, you know, you look at my my YouTube face, and it's the camera may not be super good, and people always assume that I'm like, I don't know, 20s to 25s or whatever it is, but I have many years of industry. You know, you read my profile, it goes back many decades. So and you know, I've worked in not many industries, but enough industries to know enough things. And so I don't know. Anyway, that kind of got over intention. But anyway, set realistic goals. Think about who you want to be in, you know, in 1 month, 3 months, 6 months, a year, and you know, and then it just accumulates over time. You know. All right, 7, 8 minutes in, I'm finding a way to do the problem. So let's see, 57, insert intervals. Okay. Yeah. I think for this one, I want to do something a little bit funky. I've done this problem a couple of times before, I'm pretty sure. Yeah, we have to, well, I don't know why I got wrong hands on that one, probably just sloppy. But yeah, if you want to check out those videos, you can probably just search for them. Though, this is pretty old, so I don't know. But I mean, I do them the same way, to be honest, which is with defense-based sorting. And if you watch my video from yesterday where I did, not the regular video, but the premium video, or meeting rooms. I think it's meeting rooms, right? Let me double check. Yeah, meeting rooms too. If you check that video, I kind of go over this a little bit, but today we'll play around a little bit and play with the idea of coordinates normalization or coordinates compression, and then we'll do this problem. Okay, so first things first. So all right, so we're gonna go, and this is a different thing, but yeah, so coordinates compression and then prefix sum, right? Okay, so even though I did do this on the video yesterday, but I guess it's a premium video, people may not watch it. So I'm just gonna start with the drawing stuff, and what I mean by this, right? Let's see. Sorry, I'm just bringing up the drawing thing. Oh, I have to click. Where is it? Oh, there it is. All right. Okay. So coordinate compression, right? You can't really see my screen because I have this thing up, kind of. All right, you can't really see the constraints, but basically the constraint, there are two main constraints, right? One is n, which is the number of intervals, and then the other is the x value, if you will, of the intervals, right? And what I mean by that is that, and basically coordinate compression is just compressing the coordinate so that it's in a tighter space. For example, where's my pen? But for example, let's just say you have, a lot of numbers. You have 1, 5, 20, 27. I'm keeping it sorted because it's on the timeline, right? Or number line, right? This is the idea, is that we kind of map them to basically the thing, right? Because the reason why is because nothing interesting happens in the between, because if it did, then we would just map those numbers. So then now we can compress the coordinates to basically from 1 to n, or 2 times n, something like this, right? And the reason why we do this is because, well, in this particular problem, n is equal to 10 to the 4th, or up to the 10 to the 4th, so less than. But the numbers, so I'm just calling them a sub I, or x maybe, I don't know, it doesn't matter, right? Like, you know what I'm saying. So x in the coordinates has to be less than 10 to the 5th, but it also works if it goes to like 10 to the 9, for example, because then now you compress them. That means that after compression, x will be less than 10 to the 4th, or the number of unique points, which in this case is actually 2n, so it's 2 times this, right? Because 1 unique for the beginning and 1 unique for the end, because we have intervals. Okay, so that's coordinate compression, very quickly explained. And why we want to do this is because we want to compress. We want to make sure that now we do algorithms based on this, it'll just be, the n is much smaller, right? Or like it doesn't matter how big the coordinate numbers get, because we can take advantage of this maybe in the future. Okay, and then the other thing is then now, how do we sublet interval, right? All right, let me just erase everything then. All right, right. So then now let's just say, well, 1, 2, 3, 4, 5, 6. I don't know why I'm just saying numbers to you. But yeah, now these are compressed, obviously. And now you have intervals. Let's say, you have 3 and 7, and do the 9 overlapping intervals, and you have like 1 to 3, right, and so forth, right? So one way that you can think about this is that now, let's just say we want to count the max number of overlaps or something like this, right? Or just the number of overlaps at any given point. Well, then we can just go, okay, well, we can do a for loop in a lazy way. We can just do like, okay, this is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and then 1, 1, 1. And then of course, let me change the color. If you sum it up, then you just go, straight down. This is 1, 1, the 2, 3, so that's 2. 1, 2, 2, 2, 1, 1, 0, something like this, right? I mean, and you can make it more complicated. I'm just kind of, I feel like this is enough to show an example, right? And yeah, but of course, even though this is good and this is a good representation, and hopefully a very reasonable representation, it's still not great in terms of possible complexity, because let's just say, you have 1 million intervals, or maybe a million is too much, but let's say 1,000, I don't know, it doesn't matter, right? Oops. Let's say you have 1,000 intervals and you have all of these, right? All of these, dot, 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 you have 1,000 of these. And then what happens? Well, if you do a lazy for loop, you have 1, 1, 1, 1, 1, 1, 1, and then you have to write a lot of ones, right? Dot, 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 and then, and then you sum it up. So you have to write a lot of ones. So this is where the prefix sum, the cool thing about this prefix sum is that, okay, well, let's just say we don't need to know yet, as we're processing, we don't need to know the answer to these things. I mean, at least for this particular problem, because there are other ways to handle it. But let's say you want to go from 1 to 10, right? Then you can actually just set, okay, at the beginning point before the 1, we do a +1, and then we do a subtract 1, right? So then, yeah, +1, subtract 1, and that's pretty much it. And then now the idea behind prefix sum is that now you accumulate these from left to right, or right to left, I guess. Right. You have to get the signs right, but the left to right, right to left doesn't matter as long as your signs are consistent. But yeah, and then now you can see that with the +1, this is 1, this is 1, and then now with the 3, there's another +1, so then now this is 2, 2, another +1, so 3, 3, 3, and then now -1, right? -1, and then you have 2, and then another +1 is 3, and then you have -3, so this is 0, right? So that's basically the idea. But and as you can see, we only do 1 scan and only 2 additions or bookkeeping things per interval. So that's basically the idea we're gonna use. And yeah, let's get to it. So these are the ideas. I kind of why is this button not working? There we go. But yeah, we kind of talked about, or like, you know, on yesterday's video, and that's why, you know, you should watch all my videos. Let me drink a little water. But yeah, let's do the coordinate compression first. And the idea here is just really, yeah, for S, E, and intervals, and we just want to, like I said, is get the set of unique numbers, right? So then now we can just do it, and you could write this in other ways. But you know, I'm just trying to, I don't know, write it this way. And then now, let's just say we have a sorted C. We want to sort it, and we have a list, and we want to enumerate them. So that means that we get the index and the value in C in this thing. And then now we want to know 2 things, right? One is the regular lookup, and then reverse lookup is a dictionary. So yeah, lookup.append v, right? And then reverse lookup of v is equal to index. Basically now lookup sub I maps from compressed to uncompressed, right? And then reverse lookup maps from uncompressed to compressed, right? Yeah. Okay. So then now we can handle the intervals with prefix sum, right? So then now, let's just say we have, I don't know, prefix is equal to 0 times length of C plus 1 maybe, I don't know. I know that's a 2. I don't know why I typed a 2. Something like this, right? And I always just do extra ones because why not? It doesn't really change that much. But it's 2 times, because that's the number of. Actually, I don't need the 2, do I? Huh? I forgot. I was thinking about n. That's why. But here, this is the number of unique things. So then we can just do 0, and we have unique plus 1, so that you have the no set, right? The 0 element set. That's at least that's my convention. You know, you could do for whichever one you like. And then now we do the same thing. We go for the intervals again, and then now we want. Well, these are uncompressed, so to get the compressed one, we do an or lookup of S, right? So we do, and then now, as we said, we do a prefix of 1, and then well, I mean, it's gonna be this. It's either this or plus 1. It really depends on how you do the yeah, I think this should be it. It depends on if it includes that number, which for this one is a little bit awkward. I guess it doesn't contain the space between 2 and 3. So we might have to be a little bit careful with how I handle this. But that's basically the idea, right? And then now that we're done, we can do for I in range in range of length of C or length of prefix. Actually, starting from 1, I guess doesn't really matter as long as you're consistent, right? And then now you should have all the intervals. So I'm gonna just print this out for visualization, right? And also double check to see my answer. That's not. Oh no, maybe that's right. Yeah, okay. Is it? Oh, I mean, well, I didn't add the 2 to 5. Oh, I guess this is right because of the path compression. That's true. Yeah. I forgot about path compression. Or sorry, coordinate compression. Different compression. But yeah, and then now we want to add a new interval. I forgot to add the new interval, so yeah, that's my fault. But maybe we could just add it. Actually, I kind of get messed up here. Yeah, because I think you need this. You need the stuff in intervals to be in this as well. I forgot about the problem, to be honest. I was just kind of confused. But yeah, I can just append intervals to new intervals, and I think that should be good. Easy, right? That's the thing with understanding your code, is that you can find like easy way to adjust things. I just want to double check real quick. Yeah, because two things are on 2, and then you have 3. This is 3. Yeah, right. So then now, how do we enter this problem given this, right? Well, we know that the end of an interval is something going from non-zero to 0, and the beginning is from 0 to non-zero, right? So then now we can just go through it again, right? So maybe we have for I in range of, man, I cannot type. Hopefully I don't make silly mistakes, but that's fine, right? So basically, yeah, if prefix sub I minus 1 is 0 and this one is greater than 0, then we have a beginning, right? So maybe I have a, I don't know, just a start is equal to none, start is equal to I, but I is the compressed coordinate, right? So to look it up, we have to do lookup. Or you could do it later, it doesn't really matter, right? As long as you're consistent. And yeah, I guess, yeah. And this is the end, maybe. I may be off by 1 on this one. I have to be careful. But yeah. And then now you want to say look up to but then we can actually just append this, right? So yeah. So answer that append, start, look up, and then start is equal to none, just for, I don't know, debugging quality in theory. And yeah, maybe we're off by 1, but the idea should be hopefully good. Oops, this should be an array. Oh, yeah. I messed up here again. Because I did a prefix sum for this 0 prefix, but actually it doesn't, because I forgot to add in like a negative infinity for demonstrating the left. So yeah, okay, fine. So then like we can add, you could add 0 for this one because the numbers don't go, oh actually it does start at 0, so actually that's pretty bad. But yeah, so you just use like a negative infinity just for, so that you have because that's how I define my prefix sum, that's why it's a little bit off. But because of this, then we can do this easier actually. Because then now you have I minus 1 is true, right? Because the first item will always be 0, right? So that holds that invariant, which I assumed, but then I forgot about the offset stuff. But yeah, let's run it real quick. Looks good. Let's give it a submit. Hopefully I don't make any silly mistakes. Ooh, I did make a silly mistake. Oh, huh. Oh, that's a good one actually. All right, we'll go with Y. This is a weird one though. Maybe that's why I got wrong answer last time. Actually, I don't. Oops. Huh. Because how do we want to represent, you know? I mean, you could do it, but I just find this very awkward. Because you have to be really careful. I think I did make an assumption that interval is has to have at least one element or have some space, but this is just so awkward. Maybe it breaks my thing, I don't know. One thing I would say is that maybe we can add, so that's where we can maybe do the thing here. But that's not good either, right? Normally you can say that, okay, now to make Y inclusive, we can just add 1 and then, you know, be off by 1 or something like this. But then now you're gonna get one into this issue here, and that's why yeah, because it connects the 2 and the 3 even though it shouldn't. I didn't know that. Okay, let me think about this for a second. I didn't know that this would be a thing. That's such an awkward. Um, that's such an awkward way to do it, though, huh? Like, why would like that's gonna be a rough case for me to handle. I just return nothing, I think. Right? Yeah. I mean, I know ways to hack it, but I don't like it. To be honest. I mean, okay. Wow. Why would they want this? And also, it's not even in the example, which is kind of weird because a zero length interval, is that an interval? Okay. Anyway, I mean, that doesn't matter. All right. So there's a way to fix this. It's a little bit awkward depending on how you want to do it, and this is maybe for me, it's just experience. So I don't know how much I want to, advocate this per se. But one thing you could do is for every you've seen the corner compression. Oops. But the idea is now you want to add space in between, like in half units, so that you can kind of be inclusive without going over connecting to the next one. Something like this, but it's very awkward to be honest. Yeah. Yeah. I mean, that's fine then, I guess. It is what it is, right? So this now, basically, it maps all the indexes from 0 to 468. So then now we can be inclusive about the end bound by having that being the odd numbers. So then now, yeah, all the endings will be odd numbers. So then your odd and even things cannot kind of overlap in a weird, funky way, because yeah, it is definitely still very awkward though. But so then now this only happens on even numbers. This only happens on odd numbers. So then we actually want to use lookup of I divided by 2, I think. That's pretty awkward. Did I mess up? Oh yeah, now prefix has to be, now it has to be 2 times bigger. Of course, because now we have 2 times the number. Oh yeah, and then now, of course. This is such a awkward hack, but I just wanted to try something new and maybe teach a little bit. And you saw most of the work. I think I went a little bit fast on the doubling of the coordinates, but the idea is that we want to start on an even number and on an odd number. So then now the beginning and ends never match. So there's always a gap. And then that gap allows us to do this thing. And that's why I kind of did it. It's a very specific thing to this particular problem, mostly because one thing that I messed up about this is that I did not expect a zero interval or zero length interval. Does it actually say that? I don't know. Yeah, I mean, I didn't read it that way, but I guess it is what it is. And this allows us to handle it that way. Yeah. So what's the complexity here? Well, we don't have any sorting. So this is actually, everything is linear, right? So yeah, this is all 1. This is linear time and space. All this stuff is linear time and space. This is linear. All these is linear. All this is linear. And so yeah, so I have linear time, linear space, and that's all we have for this one. Let me show you all of this. Okay, maybe it doesn't fit. I guess it doesn't fit because I have so many comments. Oops. I'm just trying to fit on one page so you could watch it all at once, I guess. I don't know. this is roughly right. There you go. But yeah, not gonna do an extra problem today because the contest is in like maybe 2 hours, and you know, start cooking and get some snacks. But yeah, thanks for watching. Hit the like button, hit the subscribe button, leave a comment, leave a question. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.